In this video, we're going to solve linear differential equations. So let's get started. The first step is use what is called the integrating factor. So let's start right here. So you take this one and have e integrated that one. So 2x with a minus outside dx. So the solution to this is the 2 comes outside. You have x dx. So this is e 2x squared divided by 2. Both these two cancel out. So this is e minus x squared. So this is the first step. The second step is to multiply both sides, so this one and this one, with the element that we have just found. So let's do that. So now we have e minus x squared multiplied by both sides. We can change this one to dy dx minus 2xy, and then we have the other element from the other side. We also multiply by the element that we have just found. Okay, so now here's what we do. We are going to use this one here. Okay, so this is how this works. So this is d dx. Now we have this element that comes inside, so e minus x squared, and you are missing the y, so the y is multiplying. Okay, now we have x e minus x squared. So let's continue. Now what we're going to do, we are going to integrate both sides, this part and this part. So all this stuff disappears. Let me change colors, and now we are left off with e minus x squared y, and then we are integrating this part, so x e to the minus x squared dx. So now we need to focus our attention on this part in order to solve it. So let's do that then. So what we do is we use u substitution to take care of this one. Remember that whenever you are using u substitution or integrating by parts, the whole idea is to simplify the expression so that we can work with something that is more manageable, more simple to work on. So to solve this, we're going to use u substitution. So u is equal to minus x squared du is equal to minus 2x. Now, if you look at this expression, we have x here, dx, and we have from the relationship that we found minus 2x. So we need to have the minus 2 go to the other side. So we have minus 1/2 du equals x dx. And now we have these ones that we can substitute for this one. And this one is just u. So essentially what we have to work with is the integral of e u du. Why? Because u is equal to minus x squared, which is what we have here. And then x dx, we found the relationship, which is minus half du. So in order to solve this, it's easy now. So it's minus half, and then it's eu. And because we know that u is equal to minus x squared, all we need to do now is to change the term. So minus 2 e minus x squared plus c. So our initial expression was e minus x squared y, and then we had to solve the integral from this end, and we have the solution now, which is minus 1/2 e minus x squared plus c1. And what we do here now is we take this one from this side and have it over to this side, so it's now minus x squared. And if we further simplify this, we see that this one is the same thing as this one, so this is minus 1/2, and then plus c. And because this one is negative and is on the bottom, we can have it at the top like this. So ex squared. So this is your solution to this equation. What about this one? So let's say now we have this. We have dy dx plus 1/2 y equals 1/2 e 1/3 x. So let's get started then. So the first step, again, it's finding the integrating factor. So it's this one, and we have it to the integral. So it's e and then 1/2 dx. So we get the 1/2 outside, so it's 1/2, and then it's just 1, so it's just 1x. Okay, so now that we have this one, now we are going to multiply by the terms from both ends, from this part and from this part. So it's e 1/2 x, and then we have dy dx plus 1/2 y, and then we have 1/2 e 1/3 x times 1 e divided by 2x. So this is what we have so far. So now the next step is to rearrange the terms to get this one outside. So let's do that. So it's d dx and then e 1/2 x y. And then if we notice, we have both these two terms here, and we can, it's the same base, we just add the exponent. So 1/3, you can multiply it by 2, so it's 2/6, and this one is by 3, so it's 3/6. So 2/6 by 3/6, that's 5/6. So this is 1/2 e 5/6 x. So the next step, now that we have this, the next step is to integrate both sides. And when we do that, we get rid of all the stuff from here, and we get the following. So we have e 1/2 x y is equal to, now integrating this part, we have 5 divided by 6 x dx. So now let's focus our attention on this part. So to do this, we get, the first thing we do is get the constant outside, so it's 1/2 and then e 5/6 x dx. And if you remember the trick that we have been talking so far about, when you have e, it's what I call getting it to 1. And when you look at the expression, you see that it's 5/6, so in order to get this to 1, you multiply by the inverse, so it's 6/5. So you have the constant outside, you multiply by 6 divided by 5, and then the rest you leave the same. So 5/6 x, and this is the solution to this one. So you get, so 6 divided by 10 e 5/6 x plus c. So 6 divided by 10, that's the same thing as having 3 divided by 5 e 5/6 x plus c. So now we have the expression, and initially we had e 1/2 x times y equal the whole integral that we were trying to figure out, and now we have. So all we need to do now is just get this guy here, so it's 3 divided by 5 e 5/6 x plus c1, and now we can get this one out and get this on at the bottom. And if you notice, we have two terms here separated by a plus sign. So essentially we have two terms here. We have c1, and because this one is positive, it can go up negative. So it's 1/2 minus 1/2 x, and then plus, and then you have the same terms here and here. And because this one is 6 and this is 2, so all we do here is 3/5, and then e, same base, 5/6 minus, what's this? So it's 3, so it's 3/6. So 3 divided by 6 x. So the final solution is c1 e minus 1x, and then 3/5, and then all you gotta do is solve the exponent. So it's 5 minus 3, it's 2/6, and 2/6 is the same thing as 1/3 x. So this is your solution. What about this one? So let's say now we have dy dx minus 2y equals 4 minus x. So how do you solve this one? So again, same thing. So integrating factor is equal to, so it's this one, e minus 2, then dx. So this is e minus 2x. So now we multiply e minus 2x to both sides. So we have e minus 2x, then dy dx minus 2y, and then we have this element as well, so 4 minus x, also being multiplied by the same term. So now we get rid of this one, get it outside. So we have dx e minus 2x times y equals to 4 minus x This is the same for now, minus 2x. So the next step is to integrate both sides, this one and this one. And to do that, when we do that, we get rid of the whole thing from the left. So we get just one, so it's minus 2x times y. And then we are integrating this side. So 4 minus x e minus 2x dx. So now let's focus our attention on just this part. So let's do that then. So to solve this one, the first step that we need to take is to simplify the expression a little better. So we get 4e minus 2x, and then we have minus x e minus 2x. So this is the whole integral. And to solve the integral, we will need to address each of these separately. So let's do that. So the first one, let's just call it ox here. So the first one, so 4 comes outside, and it's e minus 2x dx. Let's just solve this for now. So we already talked about the law of getting it to 1. So you have minus 2 here. So all we need to do is divide by minus 1/2. So if we do that, it's dividing it by minus 1/2. So it's minus 1/2 e minus 2x dx. So minus 1/2 comes outside. So we get minus 4 divided by 2 e to the minus 2x. So this is the same thing as having minus 2 e minus 2x. So this is the solution to the first one. Now let's work on the second one. So the second one we have minus x e minus 2x. Let's get the integral here, dx. So now we have minus x e to the minus 2x. We can get rid of the minus for now and just work on the expression as like this. So x e minus 2x dx. So we're not changing anything, just adding the minus sign in the end. So to solve this one, we're going to use integration by parts. So u is equal to x, du is equal to 1, dv is equal to e minus 2x dx, and v, remember what we did earlier on in this first expression. We are dividing this term to one that gets us 1. So when we do that, we get minus 1/2 here, because minus 2 divided by minus 1/2 is 1. So we leave the rest of the expression as is. And finally, the last term, so it's v du. So the integral of minus 1/2 e minus 2x and then du, and du is just 1, so 1 dx. So the solution to this, again, we're going to do the same thing, so get rid of the constant that comes outside, and we are going to multiply by the element that gets this to 1. So again, it's just multiplied again by minus 1/2 e to the minus 2x. So the solution to this one is 1 4 e minus 2x. So now that we have the v du, we need the whole expression, and the initial expression is u dv is equal to u times v. So u times v, it's this one times this one. So what's this? So it's minus 1/2 x e minus 2x. So that's uv minus this whole element that we have just found. So it's minus 1 4 e minus 2x. So this is our expression for this second element. And we still have the first element that we need to take care of. Remember, we have this element minus the second element that we have just found. So now we are connecting both of these. So we have this first expression that we know it's this one. So let's do that. So the first one is minus 2 e minus 2x, and then minus the whole expression that we have just found. And the whole expression that we have just found, it's this one. So minus 1/2, it's plus 1/2 x e to the minus 2x. And then this one becomes positive as well. So plus 1/4 e to the minus 2x plus c1. So this is our expression. So what we did so far, we found this whole guy. So getting the whole thing, the part that we have in yellow, going back to the beginning. So we have y is equal to the whole expression that we have just found, minus 2x plus 1 divided by 2, x e minus 2x plus 1 divided by 4 e minus 2x plus c1. And now we divide it by the element that was multiplying by y, which in our case was e minus 2x. So you can even further simplify this a bit, because this element is the same thing as this one, so we have minus 2. And then we have this element again, it's the same as this one, so it's plus 1/2 x. And then we have the same thing here, so this element is the same thing as this element, so plus 1/4 plus c1, and because this one is negative at the bottom, comes to the top as positive, so e 2x. And we can even further simplify this a bit, because this is, if this is 2, this is the same thing as having minus 8 divided by 4. We can aggregate 1/4 because it's just constants, and then plus 1.5 x plus c1 e 2x. So minus 8 plus 1/4, that's minus 7 divided by 4, plus 1/2 x plus c1 e to the 2x. So this is your solution. So let's say, well, now we have dy dx plus 2y equals 4x squared. So let's solve this one. So again, same thing. Integrating factor is equal to e to 2x, and then this is 2x. So now we are multiplying e 2x by both sides. So dy dx plus 2y, and then 4x squared times e 2x. So we now get rid of this element to get it outside. So this is the same thing as saying dx e 2x y, and then it's 4x squared e 2x. So now we are going to integrate both sides. So this whole element disappears, and we are going to find the integral of this side. So we have e 2xy is equal to the integral of 4x squared e 2x dx. So let's focus our attention on this one. So now in order to solve this, we can take the constants out to simplify this a bit. So this is the same thing as having 4 and then x squared e 2x dx. So let's solve this, and we'll use integration by parts. U is equal to x squared, du is equal to 2x, dv is equal to e 2x, and v is equal to, we've learned that when we do the integral, when an element is like e to like 2x or 3x or something, we get this element out in order to get this to 1. So in our specific case is 1/2 e 2x. And for v du, let's solve this one as well. So this is the integral of 1/2 e 2x, and du is 2x. Okay, dx. So let's solve this. So this is a constant, this is a constant. So this is 2 times 1 divided by 2, and then we have e 2x x dx. So we notice here we're going to need to use integration by parts again, but for now let's just simplify this a bit. So we have e 2x x here dx. So now we need to focus our attention on this one. So we'll use integration by parts again. So u is equal to x, du is equal to 1, dv is equal to e 2x, and v is equal to, again doing the same process, getting the constants outside in order to get the 2 to 1. So e equals to 2x, so we get 1/2 e 2x. And now for the dv part, so we have v du. So to solve this one, it's the same thing. So integral 1/2 e 2x, and du it's 1, so dx. So we get the constants outside, and then it's e 2x dx. And as we have been talking about before, so because we have a 2 here, we get it out in order to get this to 1. So it's another 1/2. So it's 1/2 times 1/2. Let's get it inside first to be clear. 2x dx. So the solution to this is 1/4, e2x. So the solution to this one, remember when we are doing integration by parts, all we are doing is saying that u dv is equal to uv minus v du. So we have this one, we have this one, we have this one, and we need to find the expression to this one. So let's do that. So uv, so that's x times v, so 1/2 e2x minus 1/4 e2x. So this element, it's this whole expression. Summarize what we have done before so it makes it clearer. We had u was equal to x squared. We had v that is equal to 1/2 e2x. And we had du that is equal to 2x. And then that dv was equal to e to the 2x. And then we found that we needed to simplify this term, which was v du, which in our specific case ended up being this element here. So when we do this, essentially we're going back to the initial expression and just rearranging the term. So this is what this means. So now we are substituting back our simplification. So this is 4 multiplying by u, so x squared times v, so it's 1/2 e2x, so it's uv minus v du, so minus 1/2 x e2x plus, because it's minus with minus, that's plus 1/4 e2x. So we can even further simplify this because we see a 4 here, this is 2, 2 and 4, so we can simplify this a bit. So this is the same thing as having 2x squared e2x minus 2x e2x plus e2x. So this was our initial expression, 4x squared e2x dx. And now we have y, it's equal to the whole expression that we have just found here. So it's 2x squared e2x minus 2x e2x plus e2x, and it's divided by this one. So this guy comes to the bottom. So we can even further simplify this expression a bit. So our expression is 2x squared. Both these cancel out. So now we keep going. So minus 2x, again, e and e cancel out. So minus 2x, and then plus 1, because this is the same as this one. And I didn't put it here, but it's the constant. So we add it in the end. So in the end, we have plus c1. And you can even further get the e on top, because if this is positive at the bottom, like the exponent, it's negative on the top. So 2x. This is your solution to our initial problem.